Welcome back to Mr. Hassan's Maths channel. Here we have question number 8 from the October 2019 International A-Level Edexcel C34 paper. This question here is about vectors and relates to questions from P4 in the new syllabus. It says, with respect to a fixed origin O, the lines L1 and L2 are given by the following equations. So L1, its equation is R equals minus 1, 1, 3 plus lambda 4, 2 minus 3, and L2 R equals 9 minus 7, 4 plus mu 3 minus 5, 2. Show that these two lines meet and find the position vector of their point of intersection. All right, so first of all, we'll just talk a little bit about what the components of this equation of a straight line is. So you have two parts to it. You have one part which is like on its own, and you have another part which is multiplied by this scalar parameter. In this case it's lambda, in this case it's mu. So what does that mean? So basically what it means, the first part is, this first part of the equation in both cases is the position vector of that particular, of any point on that particular line. Right, so for example, say this is O, and so say this is that point. We can't really draw three-dimensional vectors very easily. Supposing this is line 1. Supposing line 1 goes like this. Right? This would be the vector taking you from the origin to this point on the line. So this would be the vector minus 1, 1, 3, taking you to the line. And then this would be a vector which is parallel to the line. So one, like this would be, say, the vector from here to here would be the vector 4, 2, minus 3. Okay, from there to there. Now, depending on the value of lambda, if lambda is 2, you're going to go from here to there, that part. Plus 2 lambda means you will be 2 lots of these lines, so you end up over there. If lambda is 3, you go 3 lots of this line, you end up over there. If lambda is minus 1, you'll end up over here. Lambda is minus 2, you'll end up over there. So this tells you the direction of the line. This is like you're going along the line, that number of lengths, and this tells you how to get to the line in the first place. Right, so this could be, for example, from O to this line. Say this line goes like this. We know they intersect because it tells us intersect. Say this line goes like this. That could be, for example, it can be any point in the line. That could be how to get to the line from there to there. That could be 9 minus 7, 4. Of course, I'm not drawing it accurately. You can't because it's three-dimensional. That would be that would be the vector taking you to the line, and that would be a direction on the line. So, for example, supposing this is the vector 3 minus 5, 2 from there to there. 3 minus 5 and 2. So that would be one lot of 3 minus 5, 2. If mu equals 1, you'd end up here. So you'd go from there to there. If mu was 0, you'd end up here. Mu is 1, you end up there. Mu is 2, you end up there, and so on. There's going to be a point where they intersect, where there will be a value of lambda and a value of mu, which will take us to that same position vector. Okay, that the position vector of that point will be the same in both of these lines when they intersect. Okay, so that's what we have to do in this first part of the question. We have to basically find where we're going to prove that they intersect first. So we're not told that they intersect. We have to show that they intersect. That's the first thing. So we can't assume that they do. We have to show that they do. And once we've shown that they do, then we have to find the point at which they intersect. Okay, so sometimes this question says, given that line 1 and line 2 intersect, find the position vector of their point of intersection. In that case, you don't have to prove that they intersect. You're given that. In this case, it says show that they intersect. So we have to do that first, and then we've got to find their point of intersection. So don't throw away your marks by not doing this first part. Now, how do we show that they intersect? Well, we know that there's going to be a value of lambda and a value of mu that takes us from O to the same point. So there will be a value of lambda and mu for which these two have to be equal to each other. So we have minus 1, 1, 3 plus lambda times 4, 2, negative 3 must be equal to, at some point, 9, negative 7, 4 plus mu times 3, negative 5, 2. So what we can do here is we can say, okay, minus 1 plus 4 lambda is equal to 9 plus 3 mu. Whoops. 9 plus 3 mu. Okay, so that's one equation we can get from this. And we can say 1 plus 2 lambda is equal to minus 7 minus 5 mu. And the third equation, 3 minus 3 lambda is equal to 4 minus 5 plus 2 mu. 4 plus 2 mu. So these three equations have got two unknowns in them. So what we're going to do is we're going to choose one pair of these equations and solve them simultaneously, and we'll have a value of lambda and mu. If that value of lambda and mu satisfies the third equation, then we have shown that they intersect. Okay, so we're going to look at the numbers that we have here. We got 3, 5, 2, 4, 2. I think it's easy to use these two, 1 and 2. And I'll take equation 2 and I'll multiply it by 2. So this is going to be 2 plus 4 lambda equals minus 14 minus 10 mu. And equation 1, I'll leave it as it is. I'll have minus 1 plus 4 lambda is equal to 9 plus 3 mu. So now these two lines, if I subtract them, I will get rid of the lambda. So 2 minus minus 1 is 3. That's 0. Minus 14 minus 9 is going to be minus 23. And minus 10 minus 3 is minus 13 mu. Subtracting them, right? Okay. So that gives me, that's going to give me 3 plus 23, that's 26 equals negative 13 mu. Therefore, mu is going to be minus 2. Right, so mu is minus 2. If mu is minus 2, we can find what lambda is. Let's choose this. We've got to use these two equations, the first two. So you have 1 plus 2 times lambda equals minus 7 minus 5 times minus 2, which is plus 10. So 2 lambda is equal to that 7. The minus 7 plus 10, which is 3. 3 minus 1, which is 2. So lambda is equal to 1. So we know lambda is equal to 1 and mu is equal to minus 2. So we got to check with equation 3. Check in 3. Okay. So we have 3 minus 3 times 1. That's the left-hand side. And the right-hand side, we have 4 plus 2 times minus 2. Now this gives us 3 minus 3, which is 0. This gives us 4 minus 4, which is also 0. They're equal. That checks. So therefore, line 1 and line 2 do intersect, okay, when lambda equals 1 and when mu equals negative 2. Okay, so we proved that intersect. Now we got to find the point of intersection. All right, to find the point of intersection, we can choose any of these two and the corresponding value of lambda or mu. So what we can do now is we can, for example, you can choose either of them. Let's choose, for example, when lambda equals 1. Line 1 is going to be its position vector. You have r equals minus 1, 1, 3 plus 1 times 4, 2, minus 3. So that gives us minus 1 plus 4, which is 3, 1 plus 2, which is 3, and 3 minus 3, which is 0. Okay, so 3, 3, 0. It says find the coordinates or the position vector? The position vector. Okay, so that's the position vector of the point of intersection. And as a check to make sure that we've done the right thing, we can see when mu equals minus 2, that should take us to the same place for line 2. Okay, so we can say line 2, you have r equals 9 minus 7, 4, minus 2 times 3 minus 5, 2. So you have 9 minus 6, which is 3, minus 7 plus 10, which is also 3, and 4 minus 4, which is 0. So we can see that they're both the same. So we could have also, if we wanted to, actually, worked out lambda and mu that we found and show that they take us to the same place. That would have also proved that they intersect. And it would also found the position vector of where they intersect as well. But, the way to do it to show they intersect, okay, the general way that we know is we solve a pair of those equations, find the value of lambda and mu. If that same value of lambda and mu satisfies the third equation, then they definitely do intersect. If they don't, then they don't intersect. Okay, but here's a way to check that we got the right answer. We haven't made a mistake. The values we got for lambda and mu take this line and this line to the same place. That's where they intersect, basically. Right, so there's the answer to part B, or part A of this question. So we've shown that they meet, and we found the position or the point of intersection. Right, now for part B. In part B, it says the point P with position vector 11P negative 6, where P is a constant, lies on L1. Find the value of P. Okay, so basically, we know that this point lies on this line. So we know that there's going to be a value of lambda that takes you there. So you have lambda 4, 2, minus 3, and that's equal to 11p and minus 6. So again, we can find what the value of lambda is that takes us to this point. We know this point lies on the line. We don't have to prove it. So all we got to do, for example, take this first equation. We say minus 1 plus 4 times lambda equals 11. So we got to find what lambda is. Now the lambda is here is not the same as the lambda in the other question, all right? Because the lambda changes depending on where you are on the line. Okay, that's the value of lambda we found before, where those two lines intersect. This is a different value of lambda where the point P is on. Okay, where the point P is on the line. Okay, so the value of lambda takes you to different places along that line. So we can't just say, oh, lambda is equal to the same value we found before. No, what we have to do is we have to find the value of lambda for which this point P is on the line. And that's going to be done by solving this equation. So we're going to add 1 to both sides, divide by 4, so lambda equals 3. So P is P lies on the line when lambda equals 3, at the place where lambda equals 3. So we can say that 1 plus 3 times 2 is equal to the value of P. Therefore P is equal to 1 plus 6, which is 7. Okay, so P is equal to 7. So there's the answer for 8 part B. And then the question that was being asked, this was the actual question that was being asked to me earlier. It's saying here, somebody asked this on the channel and wanted the answer for this. So that's why I'm answering this particular question. So it says, given that the point Q lies on L2 such that PQ is perpendicular to L2, find the exact coordinates of the point Q. So P lies on the line 1. Okay, so let's just say we have line 1 over here, and say we have line 2 over here. Okay, I'm just drawing them anyhow. We can't draw them accurately. That's line 2, right? And it says we know that they intersect at a certain point. Okay, did they give us the point? Did they tell us to name anything? No, but we know they intersect at the point 330, in case we need that. So let's just say the origin is over here. Okay, so that point where they intersect is 330. So that's the origin. That's the vector 330. Okay, so it says P lies on line 1. Okay, and we know that the point position vector of P is 11, 7 minus 6. So P has so you can say O to P is 11, 7 minus 6. Is that right? Yeah. Okay, so P lies on line 1, and it says Q lies on line 2. PQ is perpendicular to line 2. So let's say P lies over here. Let me do it here so it's easier. P lies over here on line 1. And Q lies on line 2 such that PQ is perpendicular to line 2. Okay, so there has to be a right angle over here. This is Q. That's a right angle. I know the vector that takes me from O to P. Okay, doesn't want to sit there for some reason. Okay, I'll move him along there then. Okay, so that's P. Okay, and that's Q. Let me write that a bit neater. And that's the point Q. I also know the vector from O to Q. Okay, so I know the vector from O to Q. I know the vector from O to P. O to P is 11, 7 minus 6. O to Q, actually we don't know. We got to find it. This is what we got to find. So I'm going to call the vector O to Q X, Y, Z. So O to Q, I'm going to call it X, Y, Z. And X, Y, and Z will be my X, Y, Z coordinates in the end. Okay, so we got to find this point Q, which lies on line 2, and PQ is perpendicular to line 2. So we have 2 bits of information about Q that will help us. One is that Q is on line 2. Q is on line 2. All right, so that means that xyz, okay, there's going to be a value of mu that takes us to xyz. So we can set up an equation from that. We can say 9 minus 7 4 plus mu times 3 minus 5 and 2 is going to take us to xyz. Okay, and from that we can derive an equation, or three equations. We can say 9 plus 3 mu is equal to x, and minus 7 minus 5 mu is equal to y, and 4 plus 2 mu is equal to z. Okay, so there's like three equations we can form from this information here. Now the second bit of information we know is the fact that PQ is perpendicular to line 2. So what it means is the dot product of PQ, the vector from P to Q, is and the direction of line 2 will give us 0. When two vectors are perpendicular, A dot B is equal to 0, okay, when A is perpendicular to B. Okay, when the dot product of A and B is 0, when the vector A is perpendicular to the vector B. Okay, so the direction is what we're concerned about. So the direction of line 2 is given by this vector here. That doesn't tell us its direction, that tells us how to get to it. That's the direction, that determines its direction, and we need the direction of O to Q. So we know that the vector from O to Q, sorry, P to Q, not O to Q. Okay, so we know that we got to find what the vector from P to Q is. P to Q, all right? So if I want to go from P to Q, I've got to go from P to O and then from O to Q. So it's like OQ minus OP, you could say. OQ minus OP, because you're going to have minus OP plus OQ. So P to Q is basically going to be O to Q minus P to Q. P to O to Q minus O to P, sorry. Minus O to P. Right? So if I want to go from P to Q, I'm going to go minus OP plus OQ. Now, OQ is, as we said, XYZ. So this is going to be X minus, now what's the vector O to P? Okay, O to P is this. So you're going to have X minus 11, and you're going to have Y minus 7. In fact, I'll write it out here so it's clear. Not leave out any steps so everyone can see what I'm doing. So you have O to Q is X, Y, Z. Minus O to P, which is 11, 7, minus 6. So what does that give us? That gives us X minus 11 and Y minus 7 and Z plus 6. This is the vector from P to Q. Right? So I know that if I multiply P to Q with the direction of line 2, which is 3 minus 5, 2. I have 3 minus 5, 2 multiplied by this vector X minus 11, Y minus 7, Z plus 6. The dot product is equal to 0. The dot product of these two is equal to 0. Now, how do you find the dot product? It's very simple. You multiply the I components together, so 3 times X minus 11, plus then the J components together, so you have plus minus 5, so it's going to be minus 5 times Y minus 7. And then plus 2 times Z plus 6. And all of that equals 0. Okay, so now what we have here is this equation. And we have here these values of X, Y, and Z. If I replace the X with all of this, and the Y with all of this, and the Z with all of this, I will end up with equations which only have lambda in them, and I can find the value of lambda, okay, for which we can get to Q, right? That will be where Q exists. So now we have to replace the X with 9 plus 3 mu. So you have 3 times 9 plus 3 mu minus 11, minus 5 times, and for Y it's going to be minus 7 minus 5 mu minus 7. Right, and for Z, you're going to have plus 2 times 4 plus 2 mu plus 6, and all of that has to equal 0. So this is 3 times, you're going to have 3 mu minus 2, minus 5 times, you're going to have minus 5 mu minus 14. And you're going to have plus 2 times, you're going to have 2 mu plus 10 equals 0. So this is going to give you 9 mu minus 6 plus 25 mu plus 80. 14 times 5 is 80. That's 10. It's going to be 20. Is it 70 actually? 14 times 5, that's 50 plus 20. So that's 70, sorry. That's plus 70. And you're going to have plus 4 mu plus 20 equals 0. So here we have 9 plus 25, that's 34. Okay, plus 4, that's 38 mu. And here we have minus 6 plus 90, 67, that's 90 minus 6, that's 84. Plus 84 equals 0. So mu equals 84 divided by 38. Okay, 84 divided by 38, which gives you 42 over 19. Okay, so here we have 42 over 19. Actually, it's negative because it can be minus 84. So it's negative 42. So mu is equal to negative 42 over 19. I've run out of space here, so let's go to the next page. So we know that mu equals negative 42 over 19. Bit of a weird number, but, you know, I think we've done everything correct. So we assume that we're correct. So negative 42 over 19, and yeah, I just confirmed it's correct actually from the mark scheme. In the exam, I might be a bit worried when I see a number like that, and but if you're confident you've done everything right, then you could go back and check in case you made a silly mistake. Like I saw, I had with a minus sign, but that doesn't affect the weirdness of the answer. But no problem, as long as we know we're correct, that's fine. So now we know that this is on line 2, so we want to find the exact coordinates, okay, of that point Q, okay, which is such that it lies on line 1 and is perpendicular. PQ is perpendicular to line 2. So we now know how to get there from the origin. Okay, we know how to get there from the origin. It's where in line 2 we have to replace the mu with minus 42 over 19. So for line 2 we can say now the vector from O to Q is going to be given by 9 minus 7 4. And you're going to have minus 42, sorry, over 19. Minus 42 over 19 times 3 minus 5, 2. And that will give us our position vector. And then in the end, we'll write it as a coordinate. So let's just use a calculator for this. So we're going to have here 9 minus 42 over 19. And that's times 3. That gives us 45 over 19. 45 over 19. And then we have minus 7, minus 49 over 3 times minus 5. And here we'll have a negative 7. So minus 7 minus 42 over 19 times negative 5. That gives us 77 over 19. And finally, we're going to have this last one. So you're going to have, this is going to be a 2. And over here, you're going to have 4. 4 minus 42 over 9 times 2. Yep. That gives us minus 8 over 19. So we can say that the coordinates of Q, they're in coordinate form. That's the X coordinate, 45 over 19. That's the Y coordinate, 77 over 19. And that's the Z coordinate, minus 8 over 19. And there we have our answer, okay, to this last part of the question. Bit of a weird type of answer in terms of the fractions, but it's actually correct. So, you know, in the exam, you won't be able to check it's correct, but if you wanted to go back and check in case you hadn't made any mistakes, you should do so. If you find that you haven't, then that's fine. You should be confident you got the right answer. Other questions from this particular paper can be found in the playlist appearing over here. Other questions from vectors of P4 can be found in the playlist that will appear in this region. You can subscribe to my channel by clicking on this link, and you can watch a video that will appear over here how to use my channel effectively. Thank you for watching, and see you soon.